Calculus Unit 1, Day 1 and 2 notes. This is Part 5, and we have some data tables here and some graphs, and we're gonna kind of answer these limit questions pretty quickly here. Okay, so the first one, below is a table of values of an exponential function. Use the table to find the limits that follow. So when I look at this, first thing they say is, hey, as x approaches positive infinity, it looks like I'm going to go in this direction. Um, and as I keep approaching, oh, sorry, that was negative infinity. So let me go back and negative infinity. Hey, this number keeps getting bigger and bigger and bigger and bigger. So this looks like it's going to approach positive infinity. Let's actually skip over and answer this part. As I approach positive infinity, hey, 1.5, 1.125, 1.1, 1.002, it looks like as I approach positive infinity, I'm just going to be approaching 1. Okay? Um, as I approach, let's do part B, x approaches negative 3. Hey, I get closer and closer this way, closer and closer this way. It doesn't matter. There's a value there. It's going to approach 9. And same thing as I approach 1. So I approach 1 from the left and 1 from the right. It's going to approach 1.5. Okay, let's go down to the next data table. So now I have a rational function. And so as I approach negative infinity, so I'm going way out here. Okay, it looks like, so I had a huge number, and again, I'm approaching negative infinity. I have that huge, huge number, and then I get down to 1.002. Looks like I'm going to be approaching 1. Now let's approach negative 1 from the left. Well, I look here, negative 1's undefined, but as I approach it from the left, goes a value of 1 to 2001. It looks like it's getting really, really big, and it's going to keep getting that way. So this is going to approach positive infinity, again from the left. And these are, when I talk about from the left and from the right, those are one-sided limits. We'll talk about these more in a little bit. So I approach negative 1 from the right. Hey, it's negative 1, and it's going to keep going there that way to negative almost 2,000. That looks like it's going to be such a big number. It's going to keep going in that direction. That's negative infinity. Let's approach 2. Hey, it's undefined at that point, but this looks really close to 1/3 as I go from the left, go from the right. Hey, that looks real close to 1/3. It looks like it's going to approach 1/3 from the left, 1/3 from the right. It's going to be equal to 1/3. Now as I go towards positive infinity, hey, it's 0.334, 0.998. I think it's going to keep getting closer and closer to, and again, from value of 2.001 to 1,000, it just went to 0.998. I think it's going to keep going to 1. And then what is it going to be as it approaches? What's the limit of negative 1? Well, I know from the left it went to positive infinity, to the right it went negative infinity, so this limit does not exist. Okay, given this graph, let's try to answer some of the questions. And I'll just look at the graph and you guys can fill in. And we're going to practice these on some homework. So here they first ask us limit as x approaches negative 3. Here's negative 3 from the left. It's a one-sided limit, so that's going to be positive infinity. Part B, function as it approaches negative 5. So whenever they ask for just the limit, not a one-sided limit, I have to check, hey, so from the left, it looks like it's approaching negative, actually positive 4. From the right, it's still approaching positive 4. So the left and right are the same, even though the value of the function is down there. So as x approaches negative 5, the limit of the function is 4. Part C, get some different color pens here. As x approaches negative 1, here's negative 1. I'm approaching from the left. It looks like it's negative 1. Approach from the right. It looks like it's negative 1. And it's defined there. That doesn't matter right now. So we just need to know, does limit from the left equal limit from the right? And is that a real number? So part C should be negative 1. As x approaches negative 3. So here's negative 3. Hey, as I approach negative 3 from the left, it's positive infinity. Approach negative 3 from the right, that's negative infinity. One's positive infinity, one's negative infinity. So answer to C is does not exist. Okay, D, let's approach, I think that's 2 from the left. Where's 2? Here you go. So 2 from the left, I'm getting closer and closer to this value, so that is 1. 2 from the right, come in here, it looks like it's getting closer and closer to 6. And now part F says, the limit of the function as x approaches 2. Well, from the left, it's positive 1. From the right, it's 6. Therefore, it does not exist. Because remember, in order for a two-sided limit to exist, limit from the left has to equal the limit from the right. Okay, and now let's check that tails. So as x approaches negative infinity, it looks like it's approaching this horizontal asymptote, which is 2. And from the right, it's going to go on and on forever in that direction. So that's going to be positive infinity. Okay, I'll write all these in, and you guys can check what you got. Okay, so take a second just to check those for, and again, that was the graph f of x. And then next, we're going to do the same thing for g of x. And then when we get to class, we will take a look at any things you had questions on, but then we'll also start working on the homework that relates to limits. I'm going to do the same thing here. So for part A, it says we're looking at -3 as x approaches -3 from the left. Hey, that's going to be 0. Part B, -6. So whenever it just gives me one number, here's -6, I got to look, hey, from the left, I was looking at +6, sorry. So let's do -6, which is right here. From the left is approaching -4, and from the right is approaching -4. So the limit from the left equals the limit from the right. They both equal -4. Therefore, the limit as x approaches -6 is -4. -1 from the right. Here's -1. So from the right, it looks like it's approaching 2. Again, one-sided limit. Whatever it's approaching, that's the value. D, limit of g of x as x approaches -3 from the right. And is also 0. Let's get a different color pen in here. So now E, limit of the function g of x as x approaches 4 from the left. Hey, it comes down here, and then it stops, and there is nothing down here. So that is not going to exist. Okay, no real number. Okay, and now, and even though that's a one-sided limit, it doesn't exist. The limit as x approaches 4 from the right, come over here, 4 from the right, this is negative infinity, okay, because it keeps going on and on and on to that vertical asymptote. G, the limit as x approaches 4. This one doesn't exist because from the left and the right don't match up. This one didn't exist. This was negative infinity, not a real number, so it's not going to exist. The limit as x approaches, let's use green here, x approaches -4 from the left. So here's -4 down here. So as I approach from the left, oh, I did it backwards. H is -4 from the right, and it looks like it's at about 2.5, -2.5. And then the last one, I, is as x approaches -4 from the left, and this looks to be approaching -6. Okay, so hopefully that gives a better understanding of one-sided limits, two-sided limits, when two-sided limits exist, how one-sided limits help determine whether two-sided limits exist. And let me take a second to fill these in the chart. Okay, so here are those values we just talked about. They didn't ask this question, but if they said, hey, what's the limit of g of x as x approaches -3? Well, from the left, it's 0. From the right, it's 0. Therefore, the limit of g of x as x approaches -3 is equal to 0. And again, what we're seeing here is 4 from the left didn't exist. 4 from the right didn't excuse me, it was going to negative infinity. So as I approach 4, right when I get one of the one-sided limits that's not a real number, then that limit doesn't exist. Okay, and plus these aren't the same. Okay, hopefully that was a helpful introduction. A lot of notes there. That's okay. And we'll answer any questions and get you working on trying some of these limit problems on homework 1 and 2.